What's up, madlang people? So this is your free elective course, and I just decided to have these topics at on free elective because I guess this will be very helpful in your future endeavor as a physicist, a researcher, and a scientist in general. So this course is entitled Free Elective and Mathematical Models with MATLAB Applications. So we'll be discussing mostly here about studies that will be needing mathematical methods, mathematical tools, and as well as computational means or numerical analysis in order to shed light problems in physics, and not just only in physics but also across all fields in, say, chemistry, in biology, in ecology, and even in social studies and psychology, wherein we will be needing some kind of a model that will accurately describe a certain phenomena, so that we'll be able to explain it in a more scientific manner. So you already know this platform. I will not discuss anymore the Google Classroom platform. So you can already see this our course outline. Let me just run through this. Let me quickly open this. So this is the course outline for this course. So for the first two chapters, we'll be discussing on the elements of models in research and how do we define a problem. Now this course is designed in ang iyang approach is more of a research type. So it's like we will be doing this to enhance your research capability as a physicist and scientist. And then after the first two chapters, the rest of the topics are actually all about the different fields in research wherein mathematical models and computational means are very valuable. So first we have the vast diffusion model. So I guess you are already familiar with this because during our last, I think that was the CNU Fire event, wherein it showcased researches from different fields, and one of the entries there is our research, right? And I hope if you can still remember, it was held at the Tandang Sora Hall, wherein our research was presented by Sir Roy, and that the topic that he presented, which is our research, was all about the vast diffusion model. So we will try to go into that and let you feel how does vast diffusion model works and how it can be done, and how can we do some manipulations on it and produce those beautiful output and graphs. So in our case, we'll be using MATLAB as a tool in producing such output, because in MATLAB it's a lot easier because the repositories and libraries are already given and already built in the MATLAB. Then next is we have mathematical modeling of infectious diseases. This is very timely and relevant, especially we are experiencing pandemic of unprecedented event. So how do we model such infectious diseases? So we can do that by having these different approaches and models. We have SIR model, SIRD, and SEIR. This is computational modeling, or simulation in a more specific way. So we'll be simulating infectious diseases such as COVID-19 pandemic. So we can do a modeling as to when would be the peak time of infections, how many will be able to recover, and how many deaths will be predicted based on the simulation or the model. We can also do simulation on, let's say, dengue, and we also have HIV. All those infectious diseases, it actually follow similar mathematical models, and it will just differ on some parameters or constant. Then we also have community network modeling. This is all about networks. I think you've seen network models. It's very powerful. It's very beautiful and elegant because it is done more in a more on geometric siya ang dating. It's like figures, so graphs, beautiful graphs. One of the examples that this network model can be of use is the dengue incidence mapping. We can do network modeling also for the ecology studies, network traffic maybe, and some other stuff, even in Facebook network. So it can be done using community network modeling. Next, we have polymer modeling. So we'll be discussing about how polymers are being modeled mathematically and how can we simulate it using MATLAB software. So there are actually many different kind of models that are used in polymer, but in our case we'll just be focusing on these two simple models. We have the freely jointed chain and a worm-like chain. If we have time, then we can discuss the fractional Brownian motion. And lastly is, I already changed this one. Instead of a path integral in physics, we'll just replace this with Monte Carlo simulation, because I believe Monte Carlo simulation is very useful in all aspects. So most of the simulations done in physics and also in chemistry, biology, and other fields are always reinforced using Monte Carlo simulation. So more on that as we go along with our course. So for the meantime, I'll just be presenting to you the outline of our course, and then the discussion proper will commence next week. So that's all, class. So if you have questions, comments, reactions, you can just directly comment down below sa kaning video, or you can just chat me on Facebook or message me in Gmail, or you can even text me to my personal cell phone number. Okay. As for the grading system, the same gihapon siya sa electromagnetism. We have 40% problem set, 20% quiz, and then another 40% for your major exam, for a total of 100%. So that's all you need to pass this course. 60% ang passing gihapon. Okay? So, see you next time. Bye.